Hi there, welcome to John Stewart's Calculus Early Transcendentals 9th edition. This is question number 20 here. And so basically we're just told to differentiate this function. And so we basically have a standard derivative rule here, which is if you take the derivative of an exponential function x to the n, the derivative is simply n, x to the power of n minus 1. And so because we haven't really learned the chain rule in this chapter yet, our only strategy is to really use this formula. So what we have to do is we have to get rid of that squared feature, and to do that we just basically treat this function as two brackets multiplied by each other. So to do that we use something called FOIL, or the first two multiplied by the inside two, or sorry, by the outside two, multiplied by the inside two, and then finally the last two. So basically we're just doing 4 quick multiplications, and so the first term, when you do 2t times 2t, is going to get you 4t squared. Then you're going to have the outside and the inside terms, which is both going to give you a negative 6t, because negative 3 times 2t is simply negative 6t. And then you're going to have plus 9. And so our next step is we're basically going to simplify or group up like terms. Here we can see that a negative 6t and a negative 6t is the same as negative 12t. So we just simply have that f of t is equal to 4t squared minus 12t plus 9. Okay, and so now we're ready to actually take the derivative. So we just got to remember our two derivative rules, which is that x to the n is the same as the n brought in front, and 1 subtracted from the n and the exponent. And the derivative of a constant is simply 0. So in our case, we can look at the derivative of the whole function as being the derivative of the 3 parts separate. So if we take the derivative of the first part, we're just going to move the 2 down in front, and we're going to subtract 1 from the 2 in the t. And for the second term, we are going to subtract 1 from the existing one. It's kind of hard to see, but 12t is really 12t to the 1. We just normally don't write the 1 by convention. And the derivative of a constant is just 0, so that third term basically just drops off here. When we do the next step, we can say that 2 minus 1 is equal to 1, so you can just write it as 2 times 4t to the 1. And of course 1 minus 1 is the equivalent of 0, so we can write 12t to the 0. The important thing to remember is that 12t to 0 is not 0, it's 1. That's sometimes a mistake people make when they're first learning to do this. And also remember that 2 times 4 is of course equal to 8, which is hopefully everybody knows by now. So the first term just becomes simply 8t, because we don't bother to write the 1. And the second term, because t to the 0 is 1, just becomes 12. And that's how you solve this problem. Thank you very much. Yeah, if you got any more problems you'd like to have solved, just feel free to email me a copy or a picture of the question if you want, so I can kind of make a little step-by-step video, or just try to leave what textbook and what question in the comments below. Thank you very much, and goodbye.